Hi everyone, welcome to a new video time series forecasting in Python. For the sake of the algorithms, ensure you like and subscribe to my channel, and let's get started. Time series forecasting investigation is often neglected, and this video will provide a comprehensive guide plus hypothetical example followed by practical code on my GitHub in Python. So feel free to check out the code. And if you have comments, leave it below this video. Time series analysis, meaning data is organized based on a cyclical sequence. Date and time has direct influence on the target response, the variable that we try to predict from the data. And there are main components when we talk about time series analysis. We have trends, seasonality, residuals, stationarity, autocorrelation. Worth to mention that this process is not a straightforward computation. It requires a fair share of business-wise access competitors' annual reports and figures to discover business opportunities. Many analysts don't give time series analysis much weight, simply because historical data doesn't always provide an accurate prediction of future events. While this is true, time series analysis shouldn't be omitted completely from the product life cycle. It's important to consider it and critically examine both the figures and their interpretations. So, time series forecasting can serve as a baseline model against AI models, and then we can compare the results. And here, based on the data set I have used, we can see the first line plot, the blue line, reflect the original data, followed by trend component, and then seasonal component, and finally residual component. And each one reflects its true components and forecasting. It's important to remember that it depends on tabular data, labeled data. But still, how to distinguish between a regression problem versus time series problem? I find this answer from the question asked on Reddit very valuable. I will add the link so you can see the other answers as well. So, when we talk about the two parts here, the two types of problems, this person said, think of time series as an extension of linear regression. Time series uses terms such as autocorrelation and moving average to summarize historical information in order to predict future Y, the variable aka target response. In time series forecasting, prediction is the primary goal. You can get accurate predictions but may not know the underlying reason. For an example, if we have the sales for the past 7 days, we can get very predictive sales, but still we don't know the underlying cause of the historical 7 days data. Linear regression offers a very flexible overall model with the help of inference focus. Inference is related to causal inference. I have dropped a video to give you a comprehensive guide about it. Feel free to check this out. And he advised to not make a mistake of creating too complex model at the start. Simplicity is the key in order to help to communicate and understand the model, which is marked as priority. And I want to add to this part is that time series data has an order and it's indexed by time. And we cannot make any data peaking because it will affect the performance of the model. Dealing with time series forecasting has 2 degrees: baseline statistical approach and advanced approach. So the first approach is related to dealing with statistical calculation, mean, average, median, quantiles, min and max, absolute values, standard deviation, variance, etc. You can think about it as SQL queries plus data understanding plus baseline model followed by initial visualizations that cover the time series forecasting and AI model. But there are also advanced approach when we talk about linear regression model, like GBM, or any other ensemble models, statistical modeling, LSTM. It focuses more on realistic predictions with respect to the historical data and competitor information, market fluctuations, trends, and government regulations. Then we have the example, book sales store in Python. So I have used Kaggle dataset to build this model, and I have 2-degree initiation here. So the first one, when I started this project, I wanted to achieve 2 goals. One is the line plot that seems pretty dense and crowded. I wanted to tone down these fluctuations. Second point, I want to see the uprising trend line, the seasonal component and residuals. I started with the data understanding part to fathom these observations. And there are several key features that stood out to me, and I will help you with that. So the first one is the country variable that has 6 unique values, and each country has 2 stores. Then we have the product variable that has 4 unique values. And finally, the date variable that covers 4 consecutive years from 2017 to 2020. And each year has full data from January to December. And this value roughly ranged between 1,344 to 1,488. It's also worth to mention that num-solved variable is right skewed. Lastly, last cycle forecasting. So practical trick called last cycle forecasting or seasonal naive forecast. It basically taking the last cycle of the training data, then feed it to the testing data to get high accuracy. And this trick proven to work well for several reasons. One, sales patterns repeat yearly. So to forecast 2021 data, you just copy the values from 2020 or average the same day across past years. This often gives surprisingly strong baseline in retail or time series competitions. Holidays and promotions shift a bit, but the baseline demand repeats almost identical year to year. And finally, more complex models often end up just rediscovering data patterns. Can you implement this technique in Python? And that's it for today. Thanks for watching. If you find my content useful, like this video and subscribe. Thank you, and I see you in the next video. Bye.